Here we're going to talk about graphing logarithmic functions, and we're going to do so using transformations. So a few issues to consider when graphing functions is the domain. You want to consider the domain of the function. After you graph it, you want to think about the range. And then finally, you want to list any asymptotes, horizontal or vertical asymptotes, or slant asymptotes. Okay, let's go ahead and graph a logarithmic function. So we're going to, as an example, we're going to graph using transformations. We're going to state the domain, the range, and any asymptotes. And here's our function. F of x is equal to 2 take away log of x. So when you graph using transformations, you always want to start with a basic function and then build it up using transformations one at a time to get the function that you're given. So the basic underlying function here would be the log function. So right in this first graph, I'm going to graph simply y equals log x. Okay. Now because there is no written base, the assumed base is 10. So this is called the common logarithmic function. So that's always the case. When you don't see a base, then the base is really 10. It's just unwritten. So remember what log looks like. That graph is going to look something like this. So we want to plot a few points on our graph. So if x is 1, then y would be 0. So here's 1 point, maybe. So let's go ahead and I'm going to label that point over here. So that's the point 1, 0. And then if x is 10, y is 1. So if x is 10, y is 1. So this point would be on the graph as well. So the graph of basic log looks like this. Okay, let's go ahead and graph that in now. Okay, so there's our graph. I put in the point 10, 1, which was right here. I labeled the coordinates of that point. So that graph looks like this, right? Now, one thing to consider is that it's growing very slowly. So it's going out way, it's not quite getting horizontal. It doesn't have a horizontal asymptote, but only when x is 100, then y is 2. So the graph is looking like this, right? It's growing really slowly. And it does, however, have a vertical asymptote. So we're going to make note of that. It's got a vertical asymptote at x is equal to 0. And the domain is, in this case, well, the domain of any log function is all real, 0 to infinity. So 0 to infinity. That is, you have to plug in positive numbers into a log function. And we can see from the graph that the range is negative infinity to infinity. Okay, now if we go and transform that, or apply one transformation, so remember we're trying to start with log and then end up with this function. The next step would be to multiply this function by a negative 1. So what we're going to graph here would be y equals negative log x. And I'm doing that, remember, we're just trying to make one transformation at a time. And what's the effect of that negative? Well, it makes all the y coordinates from the previous graph negative. So instead of 10 positive 1, you're going to get 10 negative 1. So 10 negative 1 would be the point right here. So let's go ahead and label that point. It's going to be 10 negative 1. Let me label it right, I guess here, maybe. That might be a bad choice. Let's do it a little lower. So I'm labeling that point, the coordinates of that point are 10, negative 1. And then this point, 1, 0, remains 1, 0 because when you take the negative of the y coordinate remains 0. So it's right here. So remember, the negative, what it basically does is it causes the graph, the previous graph, to be reflected across the x-axis. So if you reflect this graph across the x-axis, what you get is something that looks like that. Okay? So the graph over here is going to look like this. Let's go ahead and graph that in. So there's our graph of y equals negative log x, and the vertical asymptote is still x equals 0. And the domain and the range have not changed. So the domain is still 0 to infinity, and the range is still negative infinity to infinity. Okay, the final step, the final transformation would be to add 2 to this function to get the last function we're interested in. So finally, we have our function y equals, now you can write negative log x plus 2, or you can write 2 minus log x. Those are the same thing. So what's the effect of the 2 here? Well, what happens is you basically transform this graph, and the transformation is you add 2 to all the y coordinates that you had. So let's see, that point was, let's label this more clearly, that point was 10, negative 1, and this point was 1, 0 still. Let's put that in there. So what's going to happen over here is instead of 1, 0, we're going to get 1, 2, because we're going to add 2 to the y-coordinate. So 1, 2 is going to be up here. Basically, this point has been shifted up 2 units. And then instead of, let's see, that point was 10, negative 1. Instead of 10, negative 1, we're going to get 10, positive 1. So that point shifted up 2 units as well. In fact, this whole graph is shifted up 2 units. I'm just using these 2 points as reference. So the final graph that we have is going to be this graph just shifted up 2 units. So it's going to look like that. Okay, let's graph that in now. Okay, and there's our final graph. Y equals 2 take away log x. And once again, the vertical asymptote is still x equals 0. And then the domain, that hasn't changed, nor is the range. So the domain is still 0 to infinity, and the range is negative infinity to infinity. Now, one thing to note, it's that this does not have a horizontal asymptote. That's right, no horizontal asymptote. Now, you might think, well, it looks like it's approaching the x-axis. It's not, though. In fact, there's no horizontal asymptote. In fact, of course, it crosses the x-axis. Where does this cross the x-axis? Well, when it crosses the x-axis, the y-coordinate would be 0. So this y-coordinate would be 0 when x is 100. Why? Because log of 100 is 2, and 2 take away 2 is 0. So this graph is looking like this, way out here, getting really, it's growing really, it's decreasing really, really slowly. It crosses at 100, so let me write that. You can write that point in way out there. You can write that there's the point 100, 0, way out there. But you should keep in mind that eventually it goes to negative infinity. Okay, so it's dropping. There's no horizontal asymptote. Okay, until next time.